Hey everyone, how are you doing? Today let's check out a nice and easy Leetcode problem called meeting rooms. Given an array of meeting time intervals, where each interval is basically a pair of start and end times, we have to determine if a person could attend all the meetings. I also want to mention that if you just started doing problems and aren't sure about how to go forward, keep in mind that Codeforces has a great article about how you can basically guess the time complexity based on the problem constraints. It might give you a little advantage and can drive you to the good direction. So if we take a look at the input size in this problem, the intervals.length, then we can see that it is between 0 and 10,000, 10 to the power of 4, which is not a great number. And based on the article, if you take a look at it, you will see that the solution is going to be somewhere between big O of n times log n and n square. We're going to get back to this later. So the first example has 3 intervals from 0 to 30, from 5 to 10, from 15 to 20. And it says that the result is false. Another important step of getting better at problem solving is to make sketches. If you're not sure about what you are doing, in this case, let's try to sketch up the 3 intervals on a basic timeline. So the first interval starts from 0 and goes to 30. The second interval starts at 5, ends at 10. And the third one starts at 15, ends at 20. We can see that the red interval is overlapping with both of the other intervals, which means that this person would not be able to be at 2 places at the same time. So they would be at red's meeting and green meetings at the same time, and after that red meeting and the orange meeting at the same time. The next example only has 2 intervals from 7 to 10 and 2 to 4. Let's try to sketch these up as well. We can see that there is no overlap between these 2 intervals. Therefore, it is going to be possible. So the result is true. Let's think about a very straightforward brute force solution. We take an interval, compare it with all the other intervals, and check for overlaps. First example's case, we take the first interval and compare it with all the other intervals. Since there is an overlap, we don't have to continue the check, but if there wasn't, then we would need to go forward and then take the second interval and compare it with all the other intervals. The question is, do we really have to compare it with all the other intervals? Because we have already made this check, right? So in this case, we only have to check for the next interval. And then we take the last interval. And since all the checks were made before, we don't have to do anything. It is also very important to think about that these are very, very small examples. So if there are multiple hundreds, thousands, or even millions of intervals, it will be very hard to see the overlaps. What is the time complexity of checking each pair? It will be big O of n squared. If we refer back to this, then we can see that we are kinda getting to the point. So for the big O n squared solution, we're going to need 2 for loops, because we need one for loop for iterating through all of the intervals, and then we need another for loop for checking the overlaps. If we are in the first interval, then we have to check the overlaps for the subsequent intervals. If we are on the second interval, we have to check the overlaps with subsequent intervals as well. So can we do better than this? Let's try to formulate a logic here. If we take 2 intervals, let's say A and B are going to be the start and end time for one interval, and then C and D are the start and end time for another interval, and we want to decide if there is an overlap, what do we need to do? We have to check if the end time for the first interval and the start time of the second interval are not overlapping, which means B has to be smaller than C. If the first interval finished earlier than the second interval started, then we know that there is no overlap. So we know this. Do we really need to do this for all of the intervals? Do we need to check each pair? If we know that the start times are in ascending order, then we can make sure that we do this check for each pair, but we only have to iterate through the list once. Because you can see that the first example is very straightforward. It is already in an ascending order. So we can check the start and end times easily. But in the second example, the start times are not ordered. So we can't just check the end time for the first interval and compare it to the start time for the second interval because they are not ordered. But if they were like then we could just check the end time for this interval and compare it to the start time of this interval, and this would tell us that there is no overlap between these two. So what if we want to sort all the intervals by their start time? Then it will be a piece of cake to look for the overlaps. Turns out sorting is big O of n times log n, time complexity, which is better than the original brute force solution. And it also refers back to this. So let's write the code for this. In order to have the logarithmic solution, we decided to sort the array based on the start times. Let's do that. And after that, we can just iterate through the list and compare the start and the end times. We can start from 0 or 1 here. It doesn't really matter if you want to check forward or backward. I'm going to check backward. So what we want to check here is if the current ith interval's start time is lower than the previous interval's end time, it means that there is an overlap. So we can just return false instantly. And if there is no overlap, we can go forward, check the next intervals. And if we got to the end, then we can return true because that means that there were no overlaps. So the ith intervals start time is smaller than the i-1's end time. Then we return false, otherwise we can return true. And that's it. Thanks for watching. I hope this was helpful. If you liked the video, like and subscribe, leave a comment or suggestion. It's very welcome. Thank you. Bye bye.